The final question we're going to go through with you is question 5 from St. Paul's School. And in this question, it's a bit unusual, the question, but quite a lot of these 11 plus questions are a bit peculiar. So here, Tilly decides to count using a clock. She starts counting from 1 in the normal way, so 1, 2, 3, 4. But then when she gets to 12, the count goes back to 1 again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a stop point at 12. Okay, so we're going to have to think about that for the rest of the question. So for example, so let me just highlight that just so that we don't forget and we can refer back to this. And so it says here that, so for example, using the method of counting 4 add 9, 4 add 9 equals 1 because 9 add 4, 1, 2, 3, 4, it goes back to 1 again. 10 add 3, so 10 add 5 rather, 10 add 5, 1, 2, 3, 4, 5, goes back to 3 again. Similarly, 3 times 5 is 15, so you've got 12, 13, 14, 15, okay? And then 2 times 13 is 26, so 12, then 24, 25, 26, that'll be 2. So what you really have to do is really know your 12 times table really well. So what you have to do in this question is know your 12 times table very well. And then you can push on from there. So here, you've got, let's see, 3 add 4 is 7. It's under 12, so that doesn't really change anything. 7 add 8 is 15 normally. So it's 15. So if you think about it, we've got 15 somewhere here as well. 15, so that should be 3. It's 12, 13, 14, 15. Yep, that's 3. 9 and 11 is 20. Well, we've got 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's going to be 8. And you've got 7 times 8 is 56, normally. And so with 56, we've got 12, 24, 36, 48, 49, 50, 51, 52, 53, 54, 55, 56. So that's going to be 8. So we keep doing that. 9 times 11 is 99. So 99, again, thinking about a 12 times table, 12 times what? 12 times 10 is 120. That's too far ahead, right? So 12 times 8 is going to be 96. So 12 times 8, 8 times 10 is 80, 8 times 2 is 16, so 80 at 16 is 96. So 96 would get us back here again. 96, 97, 98, 99 would be 3. So we get back to 3. So that's one way we can kind of go through this. There are other ways as well, but that's one way we can think about this in a quite simple method. Question B, though, it says, using the counting method, can you find 2 different positive numbers, n and m, such that n squared is equal to m squared? So this just means n times n is equal to m times m, right? So we can try that out a few times, right? So let me see. Well, I know, let's say 2 times 2 is 4, and that has to equal to something that has a 4 remainder after dividing by 12. Well, I can think of one quite quickly actually. 4 times 4 is 16, right? And so 2 times 2 equals 4, and this is 16. Normally that's not an equal sign. That means that 16 would be take away 12, 12, and then it'd be 13, 14, 15, 16. So it'd be 4 and 4. And so the 2 numbers I could think of are 2. So be careful not to write 4 and 16. It would be 2, n equals to 2. And m equals to 4, because 2 squared and 4 squared will end up with 4s for both cases. So for this question, what you might want to do is think about the cube numbers, because you've got cube numbers here. So you've got 1 times 1 times 1 is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. 5 cubed is 125. 6 cubed, 6 times 6 times 6, 216, and so forth, right? So it can, I don't think it will take you too far away from 6. Maybe 10 cube is 1,000, and it might play around with something like this. Okay, so this is quite a challenging one. This is the last question in the whole paper. So this is page 27 out of 28. So yeah, it's the last question. So it's quite a challenging one, right? So let's see. So that you got that. Now we know that if we think about the 12 hours in the clock, that means this will still be 1. This will still be 8. That's still going to be 1. That's still going to be 8. 27 is going to be 3. Right? It's going to be 3 at the end. And then you've got 64. Well, 64. 48, and then you've got 60, and then that's going to have 4 at the end. 125, 12 times 8, 120, and then you've got 5 at the end. And so you've got quite a few here. So you've got 1, 3, 8, 4, 5, 6 squared, 120, 180. What's that going to be? 216 divided by 12. That's going to be 1, 9 remaining. 96 is going to be a perfect 8. So 18. So 216 divided by 12 is 18 exactly. And so with 18, you're going to have this at 12. So that's not right either. With 1,000, if you've got 1,000 divided by 12, then you're going to have 8, 0, 0, 8, and then you've got 8 and 9 is 40 remaining. Then you're going to have 8, 12, 36, 3, then you have 4. So there we are. So they kind of use that knowledge that you're going to know 10 times 10 times 10. That's going to have 4 at the end. So it's going to be what squared? 1, 2, 3, 4 squared. And it's going to be 4 cubed rather, and 10 cubed. And so P is 10 and 4. So 4 cubed is 64. You'll have 4 on the clock, because after 60, which is 12 times 5 is 60, and then there's going to be 4 more, 64. And then you've got 1,000 here, which is basically going to be 83 12s. 83 times 12. 83 times 10 is 830. 83 times 2 is going to be 166. When you add that together, you get 996. And then there's 4 more jumps. So that would make it 12. And you've got 4 more jumps to get to 4. And that's how you can work that out. So that's a bit of a tricky one. You got to actually think about that quite a bit. B wasn't too bad, but C was a bit more painful for us, right? So have a think about that. Let us know if that helped you in this video, if that made sense. If it doesn't make sense, let us know what didn't make sense, so we can start to improve on these videos as well.